Okay, part 3. All smiles over here. Yeah, not ready to kill anybody. No, not at all. Love this. So the last one just stopped because I didn't have enough space left on my phone. So I deleted some things and now we're back to normal. And this is the voice of someone who's about to go psycho. Just kidding. Okay, so, I kind of finished the last one on the last part 2 of the video. I'm going to start this fresh and go through one entire problem the way that you would see it. So here's an example. Write a series for the function below. Find the interval of convergence and then the general term for the series. So let's say I'm given a function 3 over 1 minus 2x. This is a function. I can graph that function, but let's say I want to look at it in terms of a series. Now you might ask, why would anyone want to look at a function as a series instead? Well, one benefit to a series is that a series is just a polynomial. It's just a list of terms that really don't have any issues. Think about when we talk about like discontinuities and asymptotes and all that stuff occurs when we have fractions. Well, if I have a polynomial, I have no fractions, that's a lot easier to deal with than a fraction is to deal with. So there are times that a series is a much easier way of looking at something than the actual function that it represents. So that's part of the point, is to be able to take a function and rewrite it as a series. So how would we even begin? Well, you want to have in the back of your head what we know about a geometric series. And we know that a geometric series converges to a over 1 minus r as long as r is between 1 and -1. So as long as this is true, as long as r is between 1 and -1, our geometric series will converge, and it'll converge to this, which in the past for us was numeric. Now it's going to be variabolic. Yes, new word. So if we get a function that looks similar to this, we can say, oh, I can write that function as a geometric series. So look at what I was just given. This in blue looks a lot like this. So I can identify what is A and what is R. A is this number on top of the fraction. And as long as we have subtraction, R is that term after the subtraction sign. So everything I'm going to be given right now, function-wise, is going to look a lot like this. And I'm going to be able to take from it information. I'm going to be able to say, oh, okay, then whatever they put on the top of that fraction is A, and whatever they have in this spot is R. If this were a plus instead of a minus, well, then R would have been -2x. But this was a minus, it matches R like template. So we can, say that R is 2x and A is 3. So that means the first term is A, and this is our constant multiplier. So if the first term is 3, I multiply 3 by 2x to get the next term. Multiply 2x to get the next term. Multiply by 2x to get the next term, and so on. And just by knowing what A and R are, gets me a series. This series matches this function as long as I can write all these terms out to infinity. But there's a catch. This series only matches this function on the interval of convergence, or the IOC. Well, how do we find the interval of convergence? Well, we know that R has to be between 1 and -1. So we know that 2x has to be between 1 and -1. Solve that for x. X has to be between 1/2 and -1/2. So write a series for the function below. Oops. Done. There's the series. Find the interval of convergence. Done. And then find the general term for the series. So hold off on that for 1 second. And let's just confirm, if we were going to look at our calculator again, and we were going to graph the function 3 divided by 1 minus 2x, this function that I graphed should match that series that I found. but it should only match when x is between negative a half and a half. So I am going to go fix my window. I'm going to let my x-min be negative 0.5 and my x-max be positive a half. So I'm only looking at the space that I want this to that this will converge. And let's do it. So let's press tab and let's get ourselves a bunch of terms of the series. So 3 plus 6x plus 12x squared plus 24x to the third. Okay, looks pretty good. And remember, the strongest convergence is going to happen at the center of this interval. So in this case, at 0, we're going to have the strongest match. As we move out, the match will become less strong. But this is pretty good. These two match pretty well, and I only gave the first 4 terms of the series. So that's pretty cool. So this function is the same as this series when x is between negative a half and a half. Now, what about this general term for the series? What? Okay, general term for the series. I'm just going to erase the interval of convergence to give myself some space. That means they want us to write this in series notation. N equals blank to infinity and put something here. So this is harder to figure out. Experience is the best way to get good at it. The more you do, the more it becomes easy. But there's a couple of tricks. First trick is, I have this series all expanded. Like I didn't leave anything as just, we knew that a was 3 and r was 2x. This would be easier to get a general term if I had left it as 3 plus 3 times r plus 3 times, or this term times another r plus this term times another r, and so on. So dot, dot, dot. This would be easier for me to see the pattern if I didn't have it written like this. So I'm going to usually write it like this just because I like it, but then I will often go back and write it like this as well and say, oh, okay, what's happening here? This can be written as a series and going from something to infinity. I'm going to fill in where I want to start at the end. And this is 3 times 2x to the power of n. And as long as I start when n is 0, this will all work. When n is 0, 2x to the 0 will be 1, so I'll just get 3. When x is 1, I'll have 3 times 2x to the first. When x is 2, or n is 2, I'll have 3 times 2x to the second, and so on. So this is what we call the general term. Now there are usually more than one option for a general term. Let's say you really had your heart setting on starting with n being 1. That would be fine, but then you'd have to change this somehow. And I would have to change this power, instead of it being n, I would have to change it to n minus 1. So that the power of this becomes 0 at first, and then goes to 1 and 2 and so on. I don't like using n minus 1 if I don't have to. I'm going to use n when I can, and then I'll make my adjustment of where to start from there. Okay, so again, given a function, it should look like the sum of a geometric series. You should be able to pull from that what a is and what r is. Write the series itself, starting with a and multiplying each term by r. Find the interval of convergence by putting whatever r is between 1 and negative 1 and solving. Then go write your general term by maybe making this even more general so you can see what's happening. Okay, you have a worksheet, but I'll do the first one on the worksheet with you. So maybe start it, open it up. Actually, let's go down. I'm going to do the second one with you and have you try the first one yourself. So the second one is x over 1 plus x. So we're going to do the same routine every time. Find a, find r. A is on top. R is here, but we don't have subtraction, so r is actually negative x. You need to be able to think about this as x over 1 minus negative x. I need that to be a minus sign in order for this to be r. So if this is plus, then my r is really a negative x. Okay, so my first term is a, and I'm going to multiply every term by negative x to get to the next term. So I'm going to have x times negative x, so I'll have minus x squared plus x to the third, minus x to the fourth, plus x to the fifth, and so on. All right, so here's my function, here's my series. Now, what's the interval of convergence? Well, this has to be between 1 and -1. It's weird with the negative x. Sometimes we have some funky stuff happening. I think about this and just say, okay, well, if I want to make this positive x, then I would just divide everything by -1, and the inequality signs would flip. So I would still have the same interval of convergence as I would have as if x was positive. So really just x has to be between 1 and -1. That is my interval of convergence. And now I need a general term. So let me just write that up here. So if I were to graph all the terms of that series and I were to graph that function, I would have an exact match as long as x was between -1 and 1. General term. So this is a little bit different. Like I said, there's a few different answers you could use. When I'm looking at it this way, I'm seeing that this is x to the n. And the only exception is my powers switch every other time. So I'm going to make this -1 to the n, x to the n. Whenever I see the powers go from positive to negative, I like to use what I call an alternator. You don't have to, but I just wanted to introduce this way of thinking. What I'll do is I'll split this into two parts. This part is what's happening to the terms. This part is what's happening to the signs. So I'm going to deal with each part separately. Where do I need n to start to make this work? Well, if n starts at 1, we're good for powers. We go 1, 2, 3, 4, 5. If n starts at 1 here, are my signs correct? No, because if n is 1 here, -1 to the first is -1, but my first term is not negative. So this power needs to be either n plus 1 or n minus 1 to offset that. So this would be one way to have a general term. This would be correct. Another way to have it would have been if I did say -1 to the n minus 1. That would also be correct. It would also be correct to say -1 to the n, and start at 0, and then have x to the n plus 1. That would also be correct, because when I plug in 0, I get +1, and when I plug in 0, I get x to the first, so that would also work. I'm going to erase these, but there's more that would work. Let's say you stuck with what I said originally, and you said this is x, and then this is plus x times -x, and then plus, oh gosh, how would this work? X times -x squared. That would also work. And you could have x times -x to the n. That would also work. But then I would have to start at 0. I feel like that's uglier than the others I put in there, but this would also work. So writing the general term is going to be a struggle, at least for the beginning, until we get a little bit more practice with that. But hopefully you feel comfortable with function, series, interval of convergence, and this might be a little fuzzy. So there are 3 others, I think, for you to try in the homework. Give it a shot and see how it goes.